Welcome. Thanks for coming in. It's William, right? Hello. Can you hear me? All right, well, let's go ahead and get started. This is Austin Lassiter, and I am recording here on Tuesday afternoon, and I'm going to dive into Slack to get us started. The topic today is posted here in Slack. It's a walkthrough featuring CloudFront, Lambda, and S3. And we will be building a password-protected website using these services. This is optional, and it's an extension of the material that's available in the Cloud Foundations course. I'll be presenting live, so go ahead and interrupt me at any point if you have questions. But of course, this is also a recording for other students who aren't able to make it at this time. So before I dive in, any immediate questions, comments, thoughts? Okay, great. Well, I'm going to start off by sharing my screen. And again, welcome to everybody who's joining me. I hope you can see the screen okay. Just give me a thumbs up here on Slack. Good to go. And then I'll dive in and get started with CloudFront, Lambda, and S3. Some of this material is familiar for those of you who saw me do this walkthrough about a month ago. But for those who are new, the purpose of the tutorial is to combine or show how you would combine several services that you've been introduced to individually in the Cloud Foundations course. The approach is going to be partially lecture and partially hands-on. So the first 30 minutes or so, I will be walking through some slides. And then the second 30 minutes, I will be doing a hands-on exercise in the console. And you should be able to follow along completely on this one. This is not actually a Vocarium lab. This is a lab activity that I put together myself, and it does not require any pre-written code from the Vocarium lab website. Okay, so to get started, just as orientation, you've seen this website that I put together for our course that has, all the useful links for Cloud Foundations. And you may have noticed that it has an unusual URL, a random string followed by .cloudfront.net. And the reason why it's hosted in CloudFront is because in an earlier version of this website, it was simply an S3 static website hosted on a bucket, and it had public access. It was open and free to the world. And because we don't really have a strong LMS yet at Lambda School, I wanted to put at least some degree of authorization and authentication to keep this information from being available just broadly on the internet. So by adding a username and password, it provides a lightweight layer of authentication so that the material is only available to those with whom we share it here at Lambda. There are obviously much stronger methods for authentication, but this is a good lightweight way to get started and also shows the interaction of various tools. So building this website inspired me to go ahead and do a walkthrough that others would be able to imitate. And that is posted here on Medium. So I'll be following this pretty closely. And at the same time, you can follow along as well. Or you could also walk through these same steps using your own AWS console or the Vocarium sandbox workspace if you prefer. So I'm going to go ahead and open up my materials here on a second screen. And I'd appreciate it if you could please mute your microphone unless you have a question that you'd like to ask the group. I've also got some slides that I've made available and you can follow along with. And I will be getting started with those. There's also a GitHub repository, which I'll drop into Slack, though you can also link to this from the Medium post. So let's see here, GitHub repo with code for the website that we're going to build, just some simple CSS and HTML and JavaScript. All right, so let's get started with some slides. This material is taken from the Solutions Architect course and is a compilation of material that's available in both modules 6 and 7 of that course, introducing CloudFront, Lambda, and S3 buckets, specifically for hosting websites. So we'll see those three parts, and then we'll talk about the lab itself, which is the walkthrough. So let's get started with storing web accessible content with Amazon S3. So you want your web-based applications to be available, and you don't want them to take a long time to have to load. If your applications are unavailable, that can lead to all kinds of terrible things like revenue loss, for example, or loss of customer retention. It can also affect customer loyalty, brand image, etc. A study shows that a 1-second delay can translate up to a 16% decrease in customer satisfaction. So performance translates to higher page views, better customer experience, and higher conversion rates. And let's consider the Amazon.com website and consider how content is delivered there. In the address bar, you note that the application is transported over HTTPS, so that's secure, port 443. This tells us that Amazon.com uses the Secure Sockets Layer, or SSL. You can then note that the application content is dynamic because it's personalized for Chris in this example, which tells you that it has 0 time to live, or TTL. You can also search for items by entering user input. Static images are cached and stored in Amazon S3. So how should web accessible content be stored? Let's see how this same static content that's displayed here can be stored in an S3 bucket and then delivered to a website such as Amazon.com. Static assets include content that isn't going to change, such as text, images, and video content. And all of these things can be stored in S3. By contrast, dynamic content is typically something that's delivered, for example, by a JavaScript function or a Python function, potentially calling from a database such as DynamoDB. So static assets are, for those, S3 is going to be your best friend. Let's consider the following pattern. An EC2 instance is being used to serve static images and videos. This is not a proper use for that EC2 instance. Rather than eating up valuable and expensive compute capacity on your EC2 for images that never change, you can store them and the videos in an S3 bucket that is enabled for public web hosting. You know that S3 will be durable and that it will serve content quickly. When you use S3 to store static content, you don't need to worry about scaling out an EC2 instance in order to meet rising or falling demand. Delivery of large files from a web server can also become a problem because it causes increased network latency. So for all these reasons, using an S3 bucket instead of an EC2 server eliminates the worry about network loads and data capacity on your servers. So S3 by itself is quite powerful, but you can expand it even further by using it in conjunction with CloudFront, which is a content delivery network, or CDN, that can be used as a global caching layer in front of S3, and we'll talk about that a little further down the line on these slides. So let's continue talking about that web storage pattern. And you can already guess that where we're going with this is to get away from a server-based pattern and into a serverless pattern, like we were talking about last night. One solution is to store static asset files, such as CSS or multimedia, etc., in S3, and then serve your files from there. Objects that are stored in S3 can be accessed directly by users if the bucket is public. And if you read my previous blog post, I talk a lot about how to host a static web page that's set to public availability. What we're going to be doing today, however, has that layer of authentication over a private bucket. So when you choose an S3 bucket, you have to ask yourself how you should choose the appropriate region. You want to have more or less geographical proximity to your users in order to decrease latency. And if you do happen to have any EC2 instances, you should co-locate the bucket in the same region as the instances, as well as any other AWS services that upload and download bucket objects. It's better to locate services as close as possible to the S3 buckets that must be accessed, and this will reduce both cost and latency. Data stored in an S3 bucket is replicated across multiple data centers in the same geographic region, so it's important to carefully select that region where you store your object, because response latencies will grow when requests have to travel long distances over the internet. Another thing to consider when you set up S3 is your naming convention for your buckets and their keys. S3 contains a map of each bucket's object names, also referred to as keys. Internally, keys are all represented in S3 as strings with the form of bucket name / key name. The namespace is partitioned by a prefix, and each bucket contains multiple partitions to store object keys. Keys partition the bucket key namespace and define the partition that they are stored in. Each key is stored and retrieved based on the name that is provided when the object is first put into S3, which means that the object names that you choose actually dictate the key map, and therefore they must be unique. You can't have two buckets with exactly the same name. Finally, S3 is designed for object file storage, and it behaves like a flat file system. It will automatically scale to high request rates, similar to the way we scale up EC2 instances with an auto-scaling group, but you don't actually have to create additional instances of an S3 bucket. That's not a thing, right? It automatically scales from a single bucket when there are high request rates. So for example, an application can achieve at least 3,500 put, post, or delete requests and almost 6,000 get requests per second per prefix in a bucket. And there are no limits to the number of prefixes in a single bucket. Thus, it's simple to increase your read or write performance exponentially. Let's talk about S3 partitions. As we mentioned on the previous slide, each bucket contains multiple partitions to store object keys. S3 automatically partitions your buckets according to the prefixes of your files. Keys partition the bucket key namespace, and they also define the partition that they are stored in. Additionally, keys in S3 are partitioned by prefix. So this example shows two partitions. Those are album 1 and obviously album 2, and each of them includes photos. If you start having more than 300 requests per second, you can create a hotspot because many of the albums are named in exactly the same way. They're all in the same partition because they're all in the same folder. And a workaround is to add in front of each one of these a random prefix that will allow them to decrease latency, speed up the processing time. Okay, let's talk now about caching with Amazon CloudFront and how this can be used to speed up that same problem we just saw, which is latency on requests from an S3 bucket. So CloudFront, as we mentioned earlier, is a CDN, or a content delivery network. Its purpose is to speed up the distribution of both static and dynamic web content to users, such as HTML, CSS, JavaScript, and image files. It delivers cached content through a worldwide network of data centers that are called edge locations. This geographic proximity means lower latency when you serve content to users. This makes it more cost-effective and faster for a better user experience, as well as putting less stress on your core infrastructure. So I'm going to pause here for a second. I'm also going to jump over to Slack, and I'm going to digress from the script in order to talk a little bit about why this is especially useful. And you can ping me here in Slack or just unmute. But what CloudFront is doing is it's taking advantage of those edge locations that we're aware of across the AWS network, so that rather than every user going to the original bucket itself in order to draw the original file, they're pinging cached content that's stored regionally and thus closer to the end user, and without so many users pinging the same edge location at the same time because they are distributed across regions. So this speeds things up a lot. The downside is that there can potentially be, unless you do a workaround, which we'll talk about in a minute, The cached content may not be the most up-to-date reflection of the contents of the S3 bucket itself. All right, so pausing there for a moment on Slack, any questions or comments about S3 buckets and CloudFront so far? Good to go? Okay, excellent. So diving back into the slides. So when a user requests content that you serve with CloudFront, the user is routed to the edge location that provides the lowest latency or time delay. And this increases the best possible performance for the user. In addition, CloudFront has another type of edge location, which is called the regional edge location. It caches, this cache further improves performance for viewers and reduces the load on your origin resource, which in turn minimizes the operational burden and costs that are associated with scaling your origin resources. So it makes a cheap resource, S3, even less expensive because there are no additional charges for using this caching feature. So why is caching a best practice? Well, this is considered an architectural best practice to implement caching at multiple layers because it reduces cost and latency, and also because it increases the performance of applications. It's more cost-effective to distribute files from CloudFront than it is directly from an S3 bucket. Caching is the process of temporarily storing data or files in an intermediary location between the requester and the permanent storage. The purpose of caching is to make responding to future requests faster and reduce network throughput. For instance, in the anti-pattern that is shown on the slide, on the left hand of the slide, the S3 bucket does not use CloudFront as a caching service. 3 users request a file from the same S3 bucket one at a time, and the file is delivered to each user in the same way. The result is that each request takes the same amount of time to complete. And this process also incurs costs for the 3 separate times that the file is delivered, because as you know, you're charged on S3 not for data in, but for data out. Now let's compare the process in the anti-pattern with the better pattern, the one shown on the right, which is the best practice. Here, your infrastructure places CloudFront, which offers caching, in front of Amazon S3. In this scenario, the first request checks the file in to CloudFront. If the request does not find the file in CloudFront, then and only then does it pull the file from S3 and then stores a copy in CloudFront at the edge location that is closest to the user. The request sends a copy of the file to the user who made the request. And now when any other users in that region request that file, it's retrieved from the closer edge location in CloudFront. And the request does not have to go to S3 to get the file, which means that you're not paying for that. After the first request is complete, you no longer pay for the file to be transferred out of Amazon S3, so it's faster and it costs less. Now this slide shows yet another way to use Amazon CloudFront. So in general, you only cache static content, like an image of a kitten, the JPEG shown in this photo. However, dynamic or unique content affects the performance of your application. And depending on the demand, you might still get some performance gain by caching dynamic content in S3. For example, if there's something that needs to be personalized, the time to live becomes 0. A TTL of 0 tells CloudFront that each and every time it sees the dynamic content, it needs to go back to its origin because it will change a lot. At the same time, you can set the TTL to 5 minutes or 24 hours, depending on how long the content is good for. CloudFront can pull content from S3 in that case so that it can save the load back to an on-premises data center. And when you save a load, you have smaller instances and once again save money, and resources can perform more efficiently. So let's talk about AWS cloud architecture for web hosting. So in this example, we have our elastic load balancing load balancers in place with CloudFront in front of them. End users are directed to CloudFront via Amazon Route 53, right? That's the DNS service. The load balancers pull content and data from the S3 bucket, RDS, or Elasticache, And this can serve as a read replica if content is cached there. This architecture diagram shows how you can use CloudFront in front of your hosting architecture to decrease the number of times CloudFront must redirect requests to the load balancer and pull content. So in this example, this is a good example of reducing latency and speeding things up and reducing cost. Now, is this a serverless application? No, it's not. It has serverless components, such as an S3 bucket, but it also has EC2 instances that are pulling on RDS databases, so this would not be considered serverless, even though it does make use of caching content. So how do you enable CloudFront? First, you have to specify origin servers, such as S3 or your own EC2 instance server. CloudFront gets your files from the origin, and the files will then be distributed from CloudFront edge locations all over the world. Second, you upload your files to your origin, such as your S3 bucket. Your files are known as objects, and these typically include web pages, images, or media files. Third, you create a CloudFront distribution, which tells CloudFront which origin service to get your files from when users request the files through your website or your application. Fourth, CloudFront assigns a domain name to your new distribution, and you can see that domain name in the CloudFront console. We saw it earlier. It's just a random string of letters, or you can see that displayed here, random string of numbers and letters. The domain name can also be returned in response to a programmatic request, such as from an application programming interface or API. Fifth and finally, CloudFront sends your distribution's configuration, but not your content, to all of its edge locations, where CloudFront caches copies of your objects. And here are a few options. If you choose to use a separate CNAME or canonical name record for static content, the content is cached straight from the origin server. This process is the most efficient, but it takes a little more effort to set up and manage. If you point the entire URL or Uniform Resource Locator to CloudFront, it's easier to manage. You can use URL patterns to stage dynamic content, and again, goes through the edge locations. Of course, the advantage of using a CNAME is that it allows you to use a DNS service such as Route 53. Now let's look at how the CloudFront distributions work. In this example, Route 53 resolves example.com on behalf of the client. A request is made to the CloudFront distribution, which then looks at the S3 bucket for the content that it identifies as being stored statically. For any content that has a TTL of 0, CloudFront will go directly to the Elastic Load Balancing load balancer because it has to go back to the origin server to pull the content. In this way, CloudFront delivers both static and dynamic content. So again, in this example, there are two distribution types, the web distribution and the real-time messaging protocol, which is a distribution always being an S3 bucket. CloudFront can definitely speed up your website by caching control headers to determine how frequently it needs to check the origin server for an updated version of that file. And as we mentioned earlier, if you set the expiration period to 0 seconds, CloudFront will revalidate every request with the origin. The cache control header that is set on your files identifies both static and dynamic content. Delivering all your content through a single CloudFront distribution helps to ensure performance optimization on your entire website. And as we mentioned, you can set the expiration period or time to live. And here are various ways to retire cached content. So let's jump on down to Amazon Lambda and give a quick introduction of that and why we want to use this in conjunction with the other two services we just mentioned. So Lambda is compute power that you don't have to manage. It is the opposite of an EC2 instance. You're not responsible for its care and feeding, such as patching security systems or updating versioning. You don't have to maintain its physical location or keep an eye on its operating system. So it's an ideal solution for processing data with high availability and a limited cost because you only pay for Lambda when you run computations. Finally, it's best practice to decouple your infrastructure through a series of loose microprocesses or microservices, such as the ones that we're showing here. Here are a few examples of when you might use Lambda. And what all of these have in common is keeping the cost low because you don't have to maintain or provision any servers. Serverless computing with Lambda can begin as early as within a few milliseconds of an event, which triggers it, such as an image upload, app activity, website click, etc. So if you have a simple script that can be handled by AWS Lambda, you really should be using it. It has all the advantages and none of the disadvantages of using an EC2 instance. For example, it scales automatically, just like an auto-scaling cluster, and you will have one less instance that you'll have to worry about. Here is a list of some of the triggers that can be used to kick off a Lambda event. Almost any other service within AWS can be used as a Lambda trigger. These are just some of the most frequently used. So you'll want to consider the best way to size your resources with Lambda. There are currently 46 different levels of resource allocation, ranging from 128 megabytes and the lowest CPU power to 3 gigabytes of memory and the highest CPU power. Another constraint to consider, in addition to the runtime, which can range from 5 milliseconds to 15 minutes, is your application's memory requirement. If your application requires more than 3 gigs of memory, in that case, Lambda might not be the best solution for your application. That's really not what Lambda is designed for. And keep in mind that you're paying only for the compute that you actually use. So it's similar to how you have to specify CPU and memory on an EC2 instance. The big difference being that you don't pay for it when the lights are out. So adding more resources for Lambda means lower latency, but the compute price scales accordingly with the resource level. So you decrease latency, but you increase price on that trade-off. There is also a free tier that's available. So for example, if you kept your memory to 128 megabytes, that's the very lowest level, you would have over 3 million free seconds of compute per month. But if you raised it to 1.5 gigs, you would have less than 300,000 free seconds per month. And keep in mind that at the very most, a function can run 15 minutes, but typically it's in the space of less than 30 seconds, which means that's really a lot of calls on a Lambda function that you can get completely for free. So how do you use Lambda? Well, there are 6 steps outlined on this slide. First, you upload your, and we're going to be going through this in a little bit when we do the walkthrough. So first, you upload your code. You can do this through a zip file, or you can store it on an S3 bucket. Second, you can schedule a function to run at a specified frequency. Next, you'll want to specify the amount of compute resources, as we mentioned earlier, in terms of gigabytes of memory, and also the timeout period. Finally, you'll specify the VPC that contains these resources and where you'll want to launch the function. And here's an example of how you might use Lambda as a web server. In this particular example, a browser makes a request to CloudFront. CloudFront then retrieves the site from S3, which contains static files. The files are delivered back to CloudFront, where it caches the site. And the browser might use a client-side interface like JavaScript, which allows it to talk directly to Lambda. Postman is a popular SDK for this as well. And from there, Lambda can then write to Amazon DynamoDB or send notifications via SNS that can also be pushed out to subscribers. So that's it for the introduction and the theory. That's our first 30 minutes. Now we're going to move on to a lab where we will be having a walkthrough of these various functions. And here's an example of the architecture that we're going to build. The browser requests the website from CloudFront. CloudFront retrieves the site from S3, where there is an HTML file with JavaScript hosted in the S3 bucket. But at an intermediary step, before going back to its backend, CloudFront caches the site and also triggers Lambda each time it gets called, and it will not serve content back until it receives the username and password to authenticate that was programmed into the Lambda function. So this is what we're going to build right now using these three services. Jumping over to Slack, questions, comments, or complaints before I dive into the hands-on part of the lecture. Okay, great. Well, moving forward, let's go ahead and come now to the AWS console. And you'll notice that I'm not logged into Vocarium this time. I'm actually using my own account in the free tier located here in Northern Virginia. I'll also be using code from this GitHub website that I sent out earlier. It's just a very simple website with some kind of boilerplate HTML, CSS, JavaScript. So let's go to S3. And here is an example of a simple static website to get us started with. And this is actually the topic of a different walkthrough that I did earlier. But I just want to show you kind of what this looks like without Lambda and without CloudFront. You can have an S3 bucket that is set up to serve a static website. And if we go here to permissions, we notice that it's got a bucket policy that is set to public. And we have turned off blocking of public access. And then here in properties, we notice that static website hosting is actually turned on. It's displaying the index.html, and here's the endpoint. So I'm going to go ahead and copy this, or just click on it. And this will open up right away for a simple static website. And I'll just drop this into Slack as well if you'd like to take a look at it. Simple static website. And what I want to demonstrate by starting here is that you don't need CloudFront and Lambda in order to build a simple website using an S3 bucket. All you need to do is set permissions to public and then activate static website hosting and specify here the index document, which is typically named index.html. And you're ready to go, right? You don't need any other services. The downside of this, can you guess what it is? Is this, permissions have to be public. There are some ways to add authentication to S3, but the simplest thing to do is to add a username and password as we're about to do in the example that we're going to walk through now. And thus turn off that public access that we saw earlier, right? So down here it's set to public, but we want it to be set to objects can be public or even not public at all. Okay, so let's go ahead and start here in GitHub and take a look at these files. And these are in fact the same files that I showed a moment ago. We're just going to open them up quickly in Atom so we know what we're working with. Let's do Atom. Atom index. Right, so this is really standard stuff. It's just straight up boilerplate HTML with a CSS style sheet and a couple of very simple JavaScript functions for having a couple of buttons that will be opened when you click on them. You could get this from Bootstrap or any other simple template, not a whole lot of originality here. You would want to replace it with your own content. Notice that there are some image files. And jumping back over to the S3 console, if we go into that simple static website, each one of those image files, of course, can be displayed on its own as well, because it's been made open to the public. So this logo, for example, right, has its own object URL directly accessible from S3. We want to turn off all of that and get rid of the public access. So we're going to go back out to S3 and we're going to start by creating a new bucket. But this time, we're going to close off public access. So let's go ahead and create a bucket. Let's give it a name. Walk through, what is today? 0421 is the name of my bucket. We're going to set it up here in Northern Virginia. And you have to choose Northern Virginia for this example, by the way, because we're going to be using a feature called Lambda at Edge, or Lambda Edge. And it's still in beta, so it hasn't been rolled out to all the regions. Stuff usually starts here in Northern Virginia, and right now Lambda Edge is only available there. So notice that when we set up this bucket, this time we're actually going to block all public access. We're going to leave that on. So that's different from the website we saw just a minute ago. We're going to go ahead and create the bucket. And now that's down here at the bottom, walk through 421, and we see that it is not public. Now currently, if we go into it, it has no contents. Let's go ahead and upload. We're going to add some files. And that particular set of files is located in here. Simple website, here we go. Let's go ahead and select all of this. We don't actually need the README or the Git. We do need the index. So let's go on and proceed to next. And notice that we have this message here telling us that we are currently preventing public access. We want to leave it just like that, so we just go ahead and click upload. And now the content is there. And if we look at our bucket policy, we leave it blank. That is to say, by leaving it blank, we prevent public access. And also under our overview, we're going to see that that's prevented as well. So very clear that this is not public this time around, can't be searchable on the web. Now that we've got that up and running, let's go ahead and turn to CloudFront. And the material here that I'll be working through is taken from a good blog post that walks through this as well. I certainly am not the author of any of this. I'm definitely standing on the shoulders of giants. So we're going to go to CloudFront and we're going to create a new distribution. For delivery method, we're going to choose web and get started. There are a bunch of optional settings. Most of these will leave the same, but there are a few items that we do want to update. So under origin settings, and origin domain name, we click on this and we get a drop down of all of our different S3 buckets. There's a lot to choose from. Ours is here, walk through 421. Do we want to restrict bucket access? Yes, we do. Right, just another layer of security. And we're going to create a new identity for our origin access identity. You would not typically do this with CloudFront, by the way. You could have used CloudFront with a public bucket just to increase speed, that is to decrease latency and also decrease cost. So the steps that I'm going through here are specific to a password authenticated CloudFront distribution. Again, if you were just using CloudFront to speed things up or to lower costs, you could leave all of the defaults the way they were previously. You would not restrict access, you would not have access identity, et cetera, et cetera. So is a more secure option here. We want to update bucket policy. So it will write a bucket policy for us. Remember, we left that blank a minute ago. And then a little bit lower, we're going to look for a default root object. Down here, the default root is going to be that index.html file that we looked at a minute ago. Everything else remains the same, and we create distribution. Okay, and we do get this message that we're serving some private content, so it's not public. If we jump back out to our console, we can see that now there is a new distribution that's getting started. Now this is going to take a little bit. It can take as much as 20 minutes. So for the sake of this walkthrough, I'm actually going to go ahead and use a different distribution that I've already created, which is exactly the same as what we did in this walkthrough. It's going to be here on the March 24 example. And we can come back to this later once it has been completely deployed. But again, we don't want to wait through that 20 minutes right now. Let's go ahead while that is spinning up. We're going to go ahead and jump over to Lambda. And this is where we'll build a function with username and password authorization, and then attach it to that CloudFront distribution. So here in Lambda, we'll start off by creating a function. We're going to author from scratch. We're going to give it a name. I'm going to call this my function. Camel casing is common, and again 0420. Now the runtime is going to be Node.js. We got this function, I didn't write it myself. I have it from another author on Stack Overflow. It's written in JavaScript. And down here under choose or create an execution role, we need to create a role that will allow it to talk to CloudFront. So this is a little different from what we did last night. We're going to create a new role from policy templates. And this means that there are some pre-written roles that come kind of baked in with AWS. Click on here, there's a bunch that we can recognize, we can choose from. And the one that we want is basic Lambda edge permissions for CloudFront trigger. Again, this will only be available in the Northern Virginia region. If you're in Ohio or out west, you will not see this policy template available to you because Lambda Edge hasn't been launched in those regions yet. Let's go ahead and create our function. Oh, I have to give it a name. Let's just call it my. Okay, so it's creating my function for me. Okay, we get the green bar, letting us know that this has worked smoothly. My function is here. It currently has no trigger, and it also just has this sort of boilerplate code that comes with every Lambda function, sort of a hello world. We're just going to go ahead and delete that. And the appropriate code we're going to copy from the walkthrough here in Medium. This is JavaScript. We copy and paste it. It is also common to save your code to an S3 bucket. It's an alternative, but we can just paste it here into the index.js. And notice that what is it doing? It's well commented. It is getting the request headers. It's configuring the authentication. Our username is just user and our password is pass. It turns those into an auth string. And then here has an if statement that if it receives the appropriate response, it goes to status. If it receives rather the inappropriate response, it goes to 401 for unauthorized. And otherwise, then it will continue processing the request if the authentication is passed, and it will pass that request to CloudFront and to distribute the cached content. So we're going to go ahead and click Save. And now we'll scroll back up to the top, and we need to add a trigger. So first, under Actions, we're going to deploy to Lambda Edge. And remember, we created a role for that a minute ago using a policy template. And now it's going to ask what trigger we would like to configure in CloudFront. I'll have several that are available to me. This is one that I created previously for the March 24 example. But you could also copy and paste a different distribution name from CloudFront if you needed to. We're going to leave the cache behavior as all. And the CloudFront event will be toggled over to viewer request, meaning that someone is trying to view the website. We'll want to include the body of the request. And we'll also want to confirm the acknowledgement here. Now we'll deploy. Okay, so you can ignore the error warning. And once again, it is going to, oh, you know what? I know why this is doing it, because I actually have two edge functions on exactly the same CloudFront distribution. So to get around this, what we'd want to do is go back to and find the specific distribution name of the one that's still getting deployed in CloudFront. Under distributions, there it is. It's actually gone all, it came through faster than I expected. So I'm going to go ahead and I'm going to copy this, bring it back over to Lambda Edge and replace as follows. And once I start it, now it appears in the dropdown, everything else the same, and now I should be able to deploy it successfully without that error message. Now I can X out. It is a glitch. I've noticed that after you deploy, it still leaves this window open, so we'll want to get rid of that. But it tells me that I have successfully created the function and associated it with a CloudFront trigger. And notice that down here on the left, the trigger has been added through the actions that we did associating it with Lambda Edge. So going back over to so we're done here in Lambda. Our Lambda function has been written and its trigger has been associated. Now back over here in CloudFront, notice that our status has once again switched to in progress because it is now replicating across all edge locations that are available for the first time. Content is being cached. That's going to take a little while. This part does take about 20 minutes because it's populating out to basically every region and edge location across the entire Amazon network for the first time. So there's a cached copy of my content saved across the network. So because that one's not quite ready yet, let's go ahead and use this one instead, which again is just a replica of what we did today. And if I scroll down, I can see that under General, it has a domain name as follows. So I'm going to copy that, paste it into my browser, and I'm actually going to use incognito mode because this is probably already cached in my own browser since I was working on it earlier today. So and it wouldn't ask for a username and authorization. but in incognito it will. And remember, the username was just user and the password was just pass. This is what my Lambda function is triggering. Remember, this is coming from Lambda. You go ahead and sign in. Oh, look at that. Okay, this is a previous version and I must have changed the password on that. All right, let's see if I got a different one. So, well, this is what you would expect, right? It's coming up as unauthorized because I don't actually remember the username and password on that one. Let's try a different one. And the one that I have here in the Medium post I know is available because I checked that out this morning. And that is located. Here it is. This is the one, D22RKM, which just out of curiosity is this guy right here. So it's the next one down, right? So on this one, I'm going to go ahead and I'm going to grab that URL. If I needed to find the username and password on that other one, by the way, I'd have to go poke around until I found the appropriate Lambda function. I must have been feeling creative that day. That must have been around St. Patrick's Day. And that one works successfully and it's already cached. So if I do it in incognito, it will ask me for the username and password, which is user and pass. And that works smoothly. And now we're on our website, which is a very simple website with just some really simple JavaScript functions, right? Doesn't do a whole lot. Displays one cached JPEG, et cetera, et cetera. So you could actually stop at this point, but there is one additional step that's worth considering, which is what happens if you need to update your HTML file. And this is your Medium, the lower portion of the Medium post talks a little about this. It says one more thing to consider. So you may want to make changes, and every time you make a change, of course, you need to re-upload a new copy of that file to your S3 bucket. But, and this is something we discovered with an earlier course back in March, it took up to 24 hours for users to see the changes that I had made. And that's because it was populating out to the CloudFront distribution, and that takes about 24 hours. So if you want to get around to that, if you want to get rid of that lag time, here in CloudFront, you have an option called invalidations. And this will basically wipe clean all cached content from edge locations so that the next time a user comes, it will call fresh content from the S3 bucket. So in this case, you can create a new invalidation and it's /index.html if it's just that one file that changed. Or if you change lots of stuff, you can do just a wildcard for everything and you'll create an invalidation and that'll take a second to populate through. And once it is completed and no longer in progress, then immediately fresh content will be served to all of your end users. Okay, so that's a wrap for the walkthrough. We're right on schedule at 4 o'clock. Took about 30 minutes to get through all of that. Again, a little bit more advanced than what you'd see in Cloud Foundations, but a good example of how you can use several services together in order to build a final product that meets a very specific user need. In this case, the need to protect our content from prying eyes by giving it authentication through a username and password. So I hope that's useful. Anybody who's on the line, any questions or comments before I wrap up? All right, well, I'm going to go ahead and stop the recording.